Alright, so now we're going to do how to solve absolute value inequalities. So that's going to require us to use our famous inequality symbols, the less than, the less than or equal to, the greater than, and the greater than or equal to. So we're going to use those when we're doing absolute value. So let's start off with an easy one. X plus 3, its absolute value is, why does it do that? It drives me nuts. Is less than 5. Alright, so basically what we're going to do is we're going to do the right side, which basically means I'm taking this thing and going and finding the absolute value, going off to the right hand side, and then when I do this one, and this is traveling on the number line by the way, and we're going to go and we're going to find it going to the left hand side. And so what happens is it's just the same thing you were doing with equations when you did the 12, minus 12, and positive 12 kind of idea. Well, this one we're going to the left side and the right side, and basically what we're going to do is graph them, and then we have some graphing to do. But because of the nature of the beast here, we're going to have some graphs on the number line, not just points, but like actual graphs, like inequality cut graphs. Alright, so when I solve this, I get x is less than 2, and when I do this one, I get x is greater than negative 8. Alright, so if I graph that on the number line, okay, I'll put negative 8 over here, and 2 over there. Let me change some color here. Let's see if I can do that by holding it down. Yes, I can. Alright, so let's say I were going to do this one over here. X is less than 2. Remember that when we don't want to be actually on the point, we leave it as an open dot, which means I can't equal to. Remember, if it's filled in, that means I can equal to. But since it says x is less than 2, then I'm going to keep the open dot. And that would describe all the numbers that go, darn it, all the numbers that go this way. Okay, and I'll continue it if I wanted to. I could continue forever in that direction if I wanted to, but I want to try to show you kind of a trick to do this. Alright, and then this one says x is greater than negative 8. So again, I'm going to put an open dot, and then that graph goes this way. So if you notice what happens is we have an and. So this guy's going forever one direction, and this guy's going forever in the other direction, and we're interested in where they both occur. This is an and. Okay, so when we work with and ors, this would be considered an and equation. So we have to know where it goes in this direction and then goes in that direction and where they both overlap. So this is an and in inequality, and it's less than. So the greater thans are going to be our ors, because we've been studying both the and the ors, and this is considered an and. It looks like a little line segment back from geometry. So that's, again, you would use this if you were doing less than. It should look like this. And again, if I were doing an equation where how would I know if these dots get filled in or not, it's really just looking at this inequality up front here. If that was an equal to, then the dots would have been filled in. Nice thing about absolute value inequalities is if you're going to fill in the dots, both dots get filled in. If you're not going to fill out the dots, then you're not going to fill either one of them in. So that makes it pretty easy. Alright, so next up, actually let me just change the page. Can I do that maybe? Let's see. Let's see if I can. Yep, I can turn a page. Alright, so if I turn a page, and I'm going to do another one. Let's do now x minus 3 absolute value is greater than 4. Alright, so let's do that one. So we're going to do x minus 3 is greater than 4. Remember that the first one you write should mimic the first one you're looking at minus the absolute value symbols. And then we got to do one going the other direction. On the number line. So we're going to make the inequality change direction. Now that's regardless of whether or not the variable has changed sign. Remember, we don't talk about that, but if this had been negative x at the beginning, all the way at the beginning, then this guy's symbol would have flipped as I did the math, and this one would flip back again once I did this math too. But because I'm just following the rules for what I'm going to do with absolute value. Alright, so I solved this thing. I get plus 3 here, plus 3 here. So now I get x is greater than 7 in that one. And then when I do the math here, and notice the math, the algebra, the arithmetic, all the way across is the same exact step. So really, if you wanted to, if it makes it easier, kind of do them both at the same time and just kind of get your answers as you go. All right, this one says less than -1. Again, I put on my number line. Don't forget the negatives go on the left and the positives go on the right. And you may not necessarily always get a positive and a negative. It's just going to the left and to the right of the number. All right, so when I do that, x is greater than 7. Remember, open dot because I didn't equal to. And then that would go off in this direction. If I do x is less than -1, then I'm going to go in this direction. Now, this can't be an and. This has to be an or. And the reason for that is because I can't be on this graph and be on this graph to the right at the same time, so it's an or. So greater thans are always or problems. All right, so now you've seen an or, and now you've seen an and. You've seen them both. And the next up, we're going to be talking about how to go from the solutions back to the graphs, which is something that my class seems to be struggling a little bit with, but are getting better every day.